right, this is the last lesson. Last lesson of grade 9. Okay. Lesson 7.7, identifying types of symmetry on the Cartesian plane. Cartesian plane is when we use the graph paper. So we're going to be going over whether it has line symmetry, rotational symmetry, whether it has both line and rotational symmetry, or no symmetry at all. All right. So I don't know if you can see this, but there's two rectangles here and here. And it's saying, what kind of symmetry does it have? Well, I'll use red here. If I put a mirror here, it has a line of symmetry there. And if I put a mirror here, it has two lines of symmetry. Now, let's see if it has any rotational symmetry. So you can see very clearly that the center of this object would be right here. So we're going to be rotating it there. And let's see. If I rotate it once and I rotate it twice, that's 2 order and 180 degrees of symmetry. Everybody remember how I get 180 degrees? That is 360 divided by 2. All right. This one's hard to see. Okay, so I'm going to redraw this because you cannot see this at all. Looks like a hat or something. And then there's a space of 2 and then here. Okay, so it's saying, does it have symmetry? Well, let's look at the line symmetry. If I put a line here, it's got symmetry, and a line here, it's got symmetry. So 2 lines of symmetry. And then if I use this as the center, I can rotate it twice. So the order is 2, which means it's got 180 degrees of rotational symmetry. Okay, this one's a little harder to see too, so I'll color it in for you. So it looks like this. You see that object better now? And this one goes like this. So in first inspection, you can see there's no lines of symmetry or anything like that. So then you might think, oh, there's rotational. But the problem is if I rotate this, the first object would have to rotate into the second object, and the second object would have to rotate into the first object, and that never happens. So there is no symmetry. Okay, example 2, it says draw the image of this parallelogram after a translation of 2 squares down and 1 square right. Draw any symmetry that results. Okay, so we're going to take, okay, and this is a coordinate plane. You can see that there's an axis and stuff like that. So we're going to go 2 down, 1 right. So I'm going to take A and go 2 down, 1, 2, and then 1 right. So there is my new, I'm going to call it A prime. I'm going to do B, 2 down, 1 right. So there's my new B prime. I'm going to draw it. Then I'm going to go C, 2 down, 1 right. There's my C prime. So then I'm going to draw it. And then D is 2 down, 1 right. So there's D prime. And so there is my new object. So is there any line symmetry here? So look around. I want to see if you can put a line of a mirror anywhere. So no. No line symmetry. Okay. Now, there's not really the center of the object, but if you were to, at 5, 3, I'm just going to do it in blue. At 5, 3, 5 over, 3 up, and if you rotate it, do you see you get 180 degrees? Now, when it's on a coordinate plane, you have to actually state where the rotational symmetry is about. So the way you say this is 180 degrees of rotational symmetry about 5, 3. That's the point. How did I know it was 180? Because if I rotate it at 5, 3, I would go once, twice. Again, to find the degrees, you take 360 and divide by the number of times you can rotate it. Okay, next one. It says here, draw the image after a translation of 2 squares down. Okay, so 2 squares down, that would be u prime. 2 down, that would be y prime. 2 down, that would be w prime. I'm going to be joining this. 2 down, that would be x prime. And then 2 down, that would be y prime and z prime. So there we go. It says what kind of symmetry. So now, again, on a coordinate plane, we know a little bit from chapter 4 how to say this. You can't just draw the line there. You actually have to come up with the equation of that line. Does anybody know what that line is? That is y equals 4. It's a horizontal line, y equals. We also have a line symmetry right here. And what is that line? That's a vertical line. That's x equals 4. So vertical line symmetry at x equals 4, horizontal line symmetry at y equals 4. Does it have rotational? If I take that center right there, maybe I'll do it in green so you can see it better. If I take that center right there and I rotate it, do you see I rotate it twice? So then we say 180 degrees of rotational symmetry about, what's that coordinate where I have that green spot? That is 4, 4. So you have to say the pivot point of it. All right, last example. It says, draw the image after rotation of 180 degrees. Draw any symmetry that results. Oh, so I meant to say 180 degrees at point A. So if that's not in your question, please add it. So if I'm going to take 180 degrees, it's up to you how you want to do this. Again, you could take the tracing paper. Okay, 180 degrees means, I'm just going to group that. Hopefully this will work good this time. Oh, it's not. It's already grouped. Okay, so rotating it 180 degrees. It doesn't matter if I go left or right because 180 degrees will be the same. So that means if the R, if it goes here, that would be, you see, from A to R, rotate, it would have to go 180 degrees all the way around. I'm just going to move this back. Oops. Oh. There we go. Okay, so is there any line symmetry? No. No line symmetry. And of course, if I'm rotating it about A, then there has to be 180 degrees of rotational symmetry at A is at 3, 3. And there you go.